Most of the time when we learn a certain analytical technique, we learn a series of steps, use some formulas, and come up with an answer. Sometimes though, when we employ that process on a problem, the problem's not asking us to use a series of steps and then find an answer. The problem's giving us the answer, and it's asking us to look for something among the steps that's missing. If you had trouble with this particular problem, keep that in mind. That is actually the gist of this particular problem. Let's take a look. Two projects of equal value, okay, have been evaluated using multi-factor productivity measure that combined labor hours at $30 an hour and overhead expense calculated at 20% of labor expense. Oh, all right. Now, before we go any further, I can take some notes, because multi-factor productivity is defined as output over a set of inputs. And what I want to take notes on is there's no mystery here exactly how long that list of inputs is. For this problem, it's apparently labor expense plus overhead expense. So I haven't decided anything, I'm just taking notes on this. All right, now the two projects were judged to have been equally productive. So that's interesting. When you calculate that ratio for each one of these projects, the overall result of the ratio comes out exactly the same. All right, fine. Although the first project used twice as many labor hours, okay, at what rate was overhead expense being charged to the second project? Oh, before we go any further, speaking of taking notes, not using any numbers, there is something rather weak in the wording of this problem. Because, it gave us information about labor expense and overhead. It said the labor expense $30 an hour, overhead expense calculated at 20% of labor expense. Now notice that the question down here is asking, what is the overhead expense rate for the second project? Well, if this 20% of labor expense referred to both projects, you wouldn't have to work this problem, because that would be the answer. Oh, you know what would have been helpful is if this problem had clarified that this 20% of labor expense, this is the overhead rate, referred to for the first project. Maybe people are assuming at this company that the 20% of labor expense is the overhead rate for everybody. But what the problem is telling you is that if these two projects balanced on multi-factor productivity, the second project couldn't possibly have been charged that rate, and we're commissioned to figure out what that rate was. Okay, so this isn't so much about calculating the actual multi-factor productivity value. It's about forensics, figuring out what that rate would have been that these two projects actually did balance or match on multi-factor productivity. All right, now how are we going to do that? Let's lay this out. Okay, first off, multi-factor productivity is output. You might be wondering, you know, there's this business about a first project, and then over here there's this second project, and their multi-factor productivity balanced. What was the output? Well, here's the ironic thing. We don't know what that number was, but notice that it said that the two projects are of equal value. That means that they have the same number in the numerator of their multi-factor calculation. Oh, now, I want to actually write that ratio for both the first project and the second project. There's this value. Let's let that value be, I'm just picking a letter to represent the value, V for value. I thought, well, maybe it could be O for output, but that looks too much like a 0. We might get confused later. Okay, V stands for the actual value of the project, because it's the same in both cases. What we're saying is that when you divide that by the combined labor and overhead expense in each case, that the overall result on each side comes out to be the same, because we were told that they tied in terms of multi-factor productivity. All right, so to finish this is really an illustration of what was described. I need to fill in down here labor plus overhead. Now, labor. Let's look at that. Labor. We were told something about labor. Oh yeah, okay, $30 an hour. I know we're going to use that. And we were told that the first project used twice as many labor hours as the second. Oh, okay, speaking of symbolics, because that's the best way to track this down, let us choose another symbol. I need a symbol for the number of labor hours used by the second project. The number of labor hours used by the second project. I'm going to choose, LH. Let LH equal labor hours of second project. Or that one right there. And you say, okay, why? Well, first off, 30 times that mysterious number, there's your labor expense. If you were actually calculating this ratio for the second project, I mean, you would do that computation. You'd find out what that number was and multiply it by 30, and that would be the total expense of labor for that particular project. Now, why did I choose a symbol for the number of labor hours for the second project? Because I was told that the first project used twice that number. So if I go over here and I say, well, you know, you're paying $30 for each hour. This project used 2 times that same amount. There's the same labor expense calculation. Okay, I don't know what that number is, but I basically spelled out what labor expense must look like for that first project. It is twice the number of hours as the second project, and it's still paying the same $30 for each hour. All right, now, remember, we're just illustrating these two ratios. What's still missing here is overhead expense, and that's the whole crux of the problem. Oh, all right. Now, the first project's the one that we know most about, right? Because the second project is the one the question's based on. In the first project, you say, all right, well, there's this 20% of labor expense. Overhead is calculated at 20% of labor expense. Oh, well, labor expense is that right there. 30 times 2 times LH would calculate labor. So if you want to calculate how much is being charged in overhead, you'd say 20% of that amount. Oh, I can fill that in. 0.2, this is a plus because this is the labor, plus 0.2 times 30 times 2 times LH. I had better extend my line between the numerator and the denominator, because that from here to here is how much we're paying in overhead for that first project. And say, all right. Then now wait, one last thing to fill in right here. Overhead expense for the second project. That's what they're asking about. That's the mysterious thing. That must be some different number for these two things when you actually calculate this to balance. All right. Oh, but symbolically, I could still spell it out the same way, because where I had 0.2 here for the 20% for the first project, I could just put an X here, like, I don't know, I'm going to try to figure it out. X times 30 times LH. Why 30 times LH? Because it's still a proportion of the labor expense. That is the overhead. Oh, all right. Now, I have this big, long illustration. What is it that I'm looking for? I'm looking for X. Oh, wait a minute. This is essentially two fractions. V divided by all this over here equals V divided by all this over here. which means that for that to be true, I can drop that business about the V in the numerator. I'm just looking for, look at the denominators basically. When would the two denominators match? If the value of the output was the same, then we're just looking for the conditions over which the value of the combined inputs is the same. And this looks really complicated, but now that I've spelled it out, I can clean this up, because 30 times 2 is 60. So this is 60 LH, right? And 0.2 times 30 times 2, put it in your calculator, that's 12. Oh, so this is 12 LH. So this over here is actually 60 LH plus 12 LH. Much easier to write 72 LH. All of this collapses to that. Don't need to bother with the numerator. I'm wondering when this is the same thing as all this stuff over here. Okay, oh, and this will clean up a little bit, right? Well, 30 LH plus, well, X times 30 LH. Can't really do any collapsing right now. Oh, but now I see that at least I can simplify this by consolidating these. I can subtract 30 from both sides. I'm revealing that 42 LH equals what's left over here, that mysterious X times 30 LH. Oh, all right. Now remember, I'm looking for X. X is what the question was about, which means that I could divide both sides by 30 LH and get X all by itself. X equals 42 LH divided by 30 LH. Oh, sweet! That means this mysterious LH cancels out. And X must be 42 divided by 30. All right, I put that in my calculator. 42 divided by 30, I get X equals 1.4. That's the answer to the problem, except he's 1.4? What was the actual question? The actual question was, what was the rate at which overhead must be charged to the second project to get these two things to be considered the same in terms of multi-factor productivity? 1.4 is 140%. That's the actual answer to this question. Apparently, in this situation, for the second project, they must be charging overhead as 140% of labor expense. Notice it was only 20% of labor expense for the first project, because that's the only way to get the two then labor productivity measures to balance, which would be the only way that the company with the two projects would consider these two things to be equally productive.